Hey guys, welcome back again. Let's start with the today's LeetCode and then GFG. Okay, let's start with the LeetCode. Okay, let's open this. I hope you solved the yesterday's problem. It was good based on the digit DP. I recorded the session, but I guess it's a long video and it was taking huge amount of net, so I just skipped. And yeah, let's see today's left and the right sum difference. We have left sum and then right sum, where left sum is the sum of the elements to the left of index I in the nums. If there is no such elements, then it's 0. And similar for right, return the answer of size n. And yeah, it looks okay. Left of sum I and the right of sum I. Meaning, first calculate the left sum, then right sum, and then just give the difference. That's what it was, I guess. So, for example, for this 10, 4, 8, 3, let's say 10, 4, 8, 3. So, let's calculate left. Okay. So there is no left, so we can put 0, then 10, I guess, then 14, and then 22. And for right, I guess 0, 3, 11, 15. And the answer will be 15, 21, 17, and 22. Difference. Okay, it's about the difference. So difference is 1. And here the difference will be 11. Here the difference will be 22. Right? So that is what we need. Right? First, let's go with the breadcode. We can have the left. Let's get the nums dot length. Okay, then put it here. And what? I guess we need only one array, right, which contains this. Let's put the answer itself. Okay, for int I 0, I is less than nums dot length plus I. So we can have n instead of nums dot length. And answer of I is equal to something like answer of I minus 1. So in left, what we were doing is, having the sum of these elements, right? Uh, that is what we were doing. Like if I is equal to 0, then what we were doing is putting 0 itself. Otherwise, in this case, the I is not 0, right? So we were putting this previous element, right? So we can have answer of I minus 1, right? Now, when we go to the next, okay, what we were doing is the previous element trying to add, so which gives the answer 4, okay, but we have 2, add the previous of left also, previous of left plus the previous of array. This is the array, right? So this plus nums of I minus 1, something like this. Okay, that is what we need. And when we go to the right, n minus 1 I is less greater than equal to 0 plus of I, sorry, minus I. So in this case, in the right case, we were having uh, we need a particular variable which tracks the previous. Initially it's 0. So if I is equal to n minus 1, then continue, because in the answer the difference is the same, whatever the answer has, right? Otherwise, first let's add the nums of I plus 1 into the previous. Okay, and answer of I will be now math.abs answer of I minus previous. This is the difference, right? And at last return answer. Let's submit. Okay, it's accepted. Now, now let's see here. Okay. What is this? Non-attacking black and white knights. Okay, non-attacking. And these are the knights. Okay. So you have two integers m and n representing the dimension of the chessboard. Find the number of ways to place a black knight and one white knight on the chessboard such that they cannot attack each other. Okay, and knights have to be placed in the different on the different squares. A knight can move two squares horizontally and one square vertically, or two squares vertically and one square horizontally, basically L shape. The knight attack each other if one can reach the other in one move. That is what it. That is how it attacks. So, for example, 2 cross 2. Now, let's put the 2 cross 2. Okay, this is 2 cross 2. Now, since for the knights, they attack something like if knight is present here, let's say. So yeah, he attacks either on this position, okay, or either on this position or this position, okay. Otherwise, this position. These are the 4 positions where he can attack. Okay, so let's try to get the formula, something like if it's 0 comma 0 comma 0, let's say, then knight can attack on this one, right? So yeah, how we can calculate? 0, 1, 2. This is 2 comma 2. This is minus 2 comma minus 2. This is minus 2 comma minus 2. This is minus 2 comma plus 2, right? If it's x-axis and this is y-axis. These are the 4 positions where knight can attack, right? And so to calculate it, we have to put one knight first and check for this particular position uh, the places where the second knight can place. So, for example, for this, when we put one knight at this location, then we can put the second knight here, 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 right? So, meaning 1 cross 3. This second knight has 3 ways to put for this particular one, right? And again, when we try to put the first knight here, okay, like first knight here, then again we have 3 choices. When we try to put first knight here, again we have 3 choices. When we try to put first knight here, then again we have 3 choices. And when we try to put, okay, this is already done, right? So let's sum up 339, 339, 9 plus 9, 16. Sorry, 18. So these many ways as I guess. Okay, these are 12 ways. Now, might happen that we end up with the duplication. Let's check first. When we put uh, the first knight here, okay, then we can put second knight here. This is one way, right? Now we can put the second knight here. This is second. This is another way. Okay, we can put here also. This is another way. Okay, and if we put the first knight here, this is one way. When we try to put this here, this is another one way. Okay, first, one thing we understand is the movement of knights, most important. Let's think later how the combination is happening. Okay, so we have moves like 2 2. Okay, then we have minus 2 2. Then we have uh, minus 2 2. Sorry, plus 2, and this is minus 2. Then we have minus 2 minus 2. Okay, and these are the 4 ways we have. And once we place one knight, then we have to check other knight's position. Okay, if it's good to place. One thing, yeah, is a bit confusing. How the combination is happening. Is there any explanation? There are 12 ways it's showing. So let's see. If one knight is here, second has 3 options to put, right? These are the 3 ways for the second. Now, if we put here, then again we have 3 ways. If we put here, then again we have 3 ways. If we put here, again we have 3 ways. And this is what 12 coming. 336 and 336. Okay, I was doing the calculation mistake earlier. Okay, sorry for that. And this is how it works. So any optimization, let's think. Okay, first do whatever we come up with. If TLE gets, we'll optimize. Okay. So first we need moves, right? Let's have our moves, meaning direction. Okay. First 2 comma 2, then minus 2 comma 2, then 2 comma minus 2, and then minus 2 comma minus 2. These are the movements. These are the moves knight can have, right? And and now how do you get this? Let's create a solve function. So we have the int which returns the base, right? So obviously we need n cross and then current directions, right? Current coordinates int j. Then what we need, these are the things that I think we need. Okay. And and okay, let me think more. So the thing is, we are trying for every possible degree. This is degree. So we start with the 0 comma 0. Okay, we place here and then try the ways where we can place, right? So so uh, how we can get the ways? Okay, so if we place this particular knight here, okay, so these are the moves where we cannot place the second knight. Okay, meaning when we place this particular knight at a position, we cannot place at these positions. Okay, and other than that, these are free to place that particular knight, right? Meaning, meaning, we have to eliminate those, those squares. We have to remove those squares from the grid, and then we can place the second knight there. So for example, we have to count how many uh, squares we have. So n cross n squares we have, right? According to it, okay, we have to uh, remove one square, okay, because on that particular square we are, right? Now these are the squares remaining, okay, and now we have to go to these directions and check if the particular move is coming inside that square, then we will remove it simply. Okay. So for in direction from dir and and let's say new I will be I plus t of 0, new j plus yes j plus e of 1 if ni is less than 0 or nj is less than 0, uh, or ni is greater than equal to m, nj is greater than equal to n, let's say. And if this is happening, meaning we have to continue. Otherwise, we have to remove that particular direction from the square. And now we left with the weights that we have. Let's say put weights instead of squares. Weights. So we remove those squares from it, and then we have these weights. So for example, for 0, comma 0, either we can put here, which is out of boundary. We can put here, which is out of boundary. We can put, let's say here, which is out of boundary. We can put here, which is out of boundary. So we have all calculated these, right? 2 cross 2 minus 1, meaning 3. We have already 3 weights. Okay. And once we have this, then again, whatever ways we have plus equal to, let's try to change the position. So n cross n, then go for I plus 1, then, I j plus 1. Okay. And here we can check if uh, I is equal to n. Okay. Meaning we can return 0 here because, okay, I'll tell you later. But if j is equal to m, then put j to 0 and I to I plus 1. Okay. And this should come first. Now we calculated 3 ways for this, then we go for this one, 0, 1. We calculated ways for this one also. These. Now we go next. So j becomes 2. Then what we do is forward, to this index, to this particular square. And for that we do something like if we reach out of boundary, then put j0 and increase the I. So we got here, then we again do this thing with j uh, again j comes here, then we go at this point, and if I is equal to n, meaning we have calculated all the answers. Okay. Then return 0 in that case. And at last return weights. And here I can return some and cross them and from 0 to 0, starting from 0 to 0. Let's see what happens. So we have the answer for 2 cross 2. Let's try another 3 cross 2. So we can come up with the wrong option, 3 and 2. Our output is 30 and the expected is 26. Let's see 3 cross 2 how it looks. Okay. First, I need to understand two integers m represent the dimension of the chess, find the way 2 cross 3, 26. Let's see 2 cross 3, 26. Okay, let's see how what's happening. 2 cross 3. So for column we considered m, and for 2 cross 3 we have to go something like this. Okay, if we put here, so right now we have 2 cross 3, which is 6 squares, right? So we remove this one because so for 0 comma 0, when we put it becomes like 2 comma minus 2, right? 2 comma plus 2, meaning 2 comma 2. So when we add 2 comma 2, then it's inside particular the m is 3 na, and the n is 2. Zero 1. Okay. Uh, so I have to do something like either okay, our moves we have to improve. Okay, so this is 1 comma 2, right? So either we need 1 comma 2, okay, and 1 comma 3, or minus 1 comma 2, minus 1 comma, okay, and in this direction, if we in this direction 1 comma minus 2, obviously this becomes minus 1 comma minus 2. These are the valid ones. Let's let Okay, so we were doing the wrong with the moves. Okay, I was doing by the uh you know one the not the zeroth index twice. Okay, let's see. Let's put another example. So let's see 10 comma 10. Now the answer is 264, but the expected is lesser. Okay. Now again we need to check here uh, the expected output for this 2324. 2324 for the 10 comma 10. Let's try 10 comma 10. 4, 5, 6, 7, 8, 9. Wait, I will have some important. Okay, where we were. Uh, for 10 comma 10, right? And let's put, okay, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, something like this. When we put here, then we have 10 cross 10, 100 squares left minus 1. So we have this many. And when we try, uh, we cannot put here, right? We cannot put here. Is there any valid position, invalid position? So we remove these two, okay? And these are the ways where we can put the second, uh, you know, second night. So we removed 99 minus 2. And when we put here, then we have, you know, this valid, invalid, this invalid, this invalid, and okay, these are the things. So again, 99 minus 0, 1, 2, 3, 3, and 99 minus, next time we have this invalid, this invalid, this invalid, and this invalid. 4. So, so, are the moves correct? 1, 2, okay. I guess uh, we are again end up with wrong moves. Okay, let me show you. We have to choose the extreme case. Let's say we are here. Okay, so we cannot place here, 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 and here. But again, we have here, here. This, 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 this. So we left these two positions to have actually 8 moves are valid ones. So uh, the same stuff, okay. But the next time I need 2 here and 1 here, 2 here and 1 here, 2 here and 1 here, 2 here and 1 here. So these are the 8 moves that are the valid ones. So now it's good. Let's take the extreme case, 200 and 225. 25. Let's see. Okay. For extreme case, it's working. Okay. So yes, thank you for watching. Bye bye.